Hi, this is Mr. Capert. This video goes along with the Trebuchet project, specifically the worksheet on mechanical advantage. So mechanical advantage is the number of times a machine multiplies the amount of force that you put in. Now, you have a mechanical advantage with a lot of different machines. Crowbar is probably one of the best examples in that you put the load, what you're trying to lift or break apart, on one side, and you put force or effort into the other side. So the lever actually multiplies the amount of force, so it takes less force to lift something. You find the mechanical advantage of a lever by taking the length of its effort arm divided by the load arm length. And so you can actually find out your effort needed to lift a load by using this equation by plugging in your mechanical advantage. We're going to use equations specific to our catapult. So for a catapult, specifically, you're going to take the counterweight arm length. So you're that arm length divided by the projectile arm length. So in this case, their counterweight arm is 4 inches long divided by 5 inches. So this right here is the projectile marble which we're throwing, and then your counterweight's on the other side, and your pivot's going to be a steel rod that goes through your throwing arm that it swings on in order to throw your marble. Now, with a lever, typically you're using it for that mechanical advantage to lift something that you normally wouldn't be able to lift on your own, such as maybe a fridge you could put on one end. You would want to put the fridge on this end and push down on the other. But with the catapult, we're not looking to lift something more easily. What we're trying to do is speed something up. We're looking at propelling the projectile faster. And so how this works is you're going to have counterweight on the short side of your arm and the marble or projectile on the long side. And it actually speeds up the projectile because let's say the counterweight falls 1 meter in 1 second. The projectile is going to raise up by 4 meters in 1 second. So this is going to be going 4 times faster because it went 4 times the distance that the counterweight did. Your counterweight's going to fall much less than the distance that your projectile is going to move. Same amount of time, so the projectile is going faster. So your counterweight's going to have to be much heavier than your projectile. In this case, notice that you have 10 kilograms for your counterweight and 2 kilograms for your projectile. This balances out perfectly. So this is going to have to be a lot more than the projectile. This wouldn't actually even throw it. Now remember, we found moments of force. So the moment on this end is 10 kilograms times 1 meter, which would give you 10 Newton meters. Well, wait a minute. No, just say kilogram meters. My bad, wrong units. And this side, you would also get 10 kilogram meters. So this is the minimum needed in order to stay level. Now, you can see in this diagram here that as the counterweight falls, it pivots on the steel rod and it throws the marble at the other end. So the counterweight fell a much smaller distance than the projectile was raised up by the arm. So it's actually going much faster than the counterweight. All right, I'm going to go through an example problem with you here. Now this is your example counterweight arm. One end you have a projectile, your marble, which is 0.05 pounds. The other end you have your counterweight, which is 10 pounds. To calculate its mechanical advantage, you use the equation that I gave you on the worksheet. Mechanical advantage equals the counterweight arm length divided by the projectile arm length. So you're going to take 4 inches divided by 12 inches. Notice 4 inches divided by 12 inches and get 0.25. No units on there. Let's see. Part B. If you were to set a 0.05 pound projectile on the throwing arm, what would the counterweight need to be just to keep it level? Now I gave you an equation for that too, where it says the counterweight, the weight of it, equals the projectile weight divided by the mechanical advantage. So the weight of the projectile is 0.05 pounds as given, and then the mechanical advantage you found on the previous part A, 0.25. Plug that in, you get 0.2 pounds. So this would actually have to be 4 times the amount of weight just to keep it level. So that's why you want to put something much heavier, like 10 pounds on this side. Now, C says, does this lever make it easier or more difficult to lift the projectile? This would actually make it much harder to lift it. We got this the wrong way around, really. But that's not what we're looking for, is lifting something. We're looking to use this lever, the mechanical advantage of it, to speed the projectile up. What I'm saying is this, unlike a normal lever, is not being used to help lift something. It's not making it easier to lift something. It's instead being used to speed something up, which in this case is the marble. All right, so that's the end of this. I do not know how to exit out of this thing right now. Give me a sec.